Night sky. A rocket rises, and something rises faster to meet it. This is Iron Dome. Roughly 90% of everything it engages, it kills. So when America announced a shield of its own, it borrowed the name the Golden Dome. There's just one problem. These two systems share a word and almost nothing else. One defends a city, the other has to defend a continent. And that changes every single piece of the machine. To understand why, you need to see what Iron Dome actually does. Because its real genius isn't the missile, it's the math. When a rocket launches, radar picks it up in seconds, and the battle computer solves one question. Where exactly will this land? And here's the part most people miss. If the answer is an empty field, Iron Dome does nothing. It lets the rocket land. Every Tamar interceptor costs roughly $50,000. So the system only spends one on a rocket that threatens something worth protecting. When it does fire, the Tamar doesn't even need to touch its target. It detonates alongside it, shredding the incoming rocket with a proximity blast. Radar, decision, intercept. The whole engagement, start to finish, in well under a minute, against rockets flying at a few hundred meters per second, over distances of 4 to 70 kilometers. Iron Dome works because the problem is small, slow, and close. Now break all three of those assumptions. Israel covers about 22,000 square kilometers. The continental United States covers 9.8 million, 450 times more ground. But area is the easy part. The threats America is planning for don't fly at a few hundred meters per second. An intercontinental ballistic missile re-enters the atmosphere at roughly 7 kilometers per second, 25,000 kilometers per hour. A hypersonic glide vehicle comes in above Mach 5 and maneuvers on the way down, so you can't simply calculate where it's going and wait for it. And instead of one radar watching one horizon, you'd need to watch every horizon at once, including attacks that come over the pole. Iron Dome's playbook follows a see it, price it, meet it close to home, which physically cannot stretch across a continent. This is why the Golden Dome isn't a bigger Iron Dome at all. It's a different machine built around one idea. Don't wait for the missile to arrive. Kill it while it's still climbing. Here's the architecture, layer by layer. Layer 1, eyes in orbit. Constellations of tracking satellites, including sensors built specifically to follow hypersonics. Watch the entire planet for launch flares, all the time. Layer 2 is the radical part. Interceptors that live in space. Hundreds of them, parked in low Earth orbit, positioned so that when a missile lifts off, one of them is already close enough to dive on it during boost phase. And boost phase is the golden window. The missile is at its slowest, burning bright, flying a predictable line, and it hasn't released its decoys yet. That last point matters more than anything because America's existing shield, 44 interceptors in Alaska and California, struggles to tell a real warhead from the fake ones. An ICBM scatters in space. Hit the missile before the decoys deploy, and that whole problem disappears. Layer 3 is everything America already owns. Patriot, THAAD, Aegis, the ground-based interceptors, stitched underneath as the last line, and binding it all together, a battle management brain that has to work at machine speed because against a Mach 5 threat, the decision window isn't minutes. It's seconds. No human moves that fast. The software has to. None of this is cheap, and none of it is proven. The program's official estimate now stands at $185 billion, and that only carries the architecture into the mid-2030s. Independent analysts put the full worst-case bill as high as $3.6 trillion. Congress has appropriated the first installments, $25 billion, then $13.4 billion more. And 12 companies are already building prototype space interceptors under contracts worth up to $3.2 billion combined. The deadline is aggressive. Demonstrate a working capability by the summer of 2028. Skeptics point out that no one has ever mass-produced interceptors at this scale, and that satellites in low orbit need constant replacement. Supporters answer that launch costs have collapsed and the technology finally exists. Both of those things can be true at once. That's what makes this the biggest engineering bet in modern defense. So, same name, different machine. Iron Dome is proven arithmetic. A $50,000 answer to a small, slow, close problem. Golden Dome is a wager that automation in orbit can change the arithmetic of defending an entire continent. Whether that wager pays off comes down to a single, brutal maneuver we haven't covered yet. Actually steering one missile into another at 25,000 kilometers per hour. No explosion. A direct hit. Metal on metal. How that's even possible, that's the next video. Subscribe so you don't miss it.